grade 10s, and welcome to the K method part of equations. This is a really fun section, but I really would appreciate it if you could please just revise your quadratic equations knowledge before this section. We did it in grade 9, but if you need to find equations in your regular maths textbook, not your AP maths textbook, just to go over a couple of quadratic equations, then please do so. Let me know if you'd like specific page numbers of examples that you could perhaps read over, because we have actually yet to cover equations in normal maths. So equations in AP maths is now a whole other level, so this might be a little bit of a challenge for you, but I've got faith. I think you're actually going to be absolutely fine. Also, I've taken the examples from this presentation. They are from the exercise that you are required to do for homework today. It's number A and G, so obviously you don't need to do those, but you do need to do the rest of them. And then I would also appreciate it if you see example 2 on page 38 before this exercise, so that you've had ample exposure to the techniques you are about to learn. Alrighty, first things first, if we have to solve for x, and you see something complicated like this, you could follow your nose and perhaps FOIL out that binomial squared, x squared plus 3x squared. You could maybe FOIL that out. You could distribute that 2 into the x squared plus 3x, the second bracket. But then you're going to see that you're going to end up with an x to the power of 4. Now that means that you need to have 4 values for x at the end of all your solving, and that is pretty hectic. We don't really have a strategy to face an equation where x is raised to the power of 4. But what we can do is identify when binomials repeat themselves, or possibly trinomials. Whenever a polynomial perhaps repeats itself in an equation, maybe we can replace that polynomial with something and deal with it a little later on. So let's think about this. If we see that this bracket, x squared plus 3x, repeats itself, why don't we just use something else to represent the bracket for now? And that can be the letter k. Let's replace each bracket with a k and then solve for k. We can forget about x for a while. So let's see, if we replace the bracket squared minus 2 times that bracket, we would end up with k squared minus 2k equals 8. Now this is a much more manageable quadratic equation because we have a k to the power of 2. Of course, to solve a quadratic equation, we need the right-hand side to equal 0. So you bring the 8 on over, and we end up with k squared equals k squared minus 2k minus 8 equals 0. And that is a beautiful trinomial that we can factorize into 2 brackets. Now either k minus 4 equals 0 or k plus 2 equals 0. So if you were to kick the constants over to the other side of the equal sign, you will see that k equals 4 or k equals negative 2. Woohoo! It may feel like we're at the end of the question because we have indeed solved an equation, but you've got to remember that we have let k equal x squared plus 3x. So instead of k being equal to 4, we actually have x squared plus 3x equals 4. Or instead of k being equal to negative 2, we actually have x squared plus 3x equals negative 2. And now we have 2 quadratic equations that we can solve. We'll end up with 2 answers for each, hence we'll have 4 answers in total. Let me work on the one on the left, bring the 4 over, factorize, and you'll get x equals 4 or x equals 1. Oopsie, that's meant to be an x equals negative 4. Please don't forget to write the negative 4 when you're taking down these notes. And on the right hand side of this column, we can say x squared plus 3x plus 2 equals 0. Factorize it, and you'll end up with x equals minus 2 or x equals minus 1. Not so bad, right? 4 answers in terms of x, not k, but merely replacing that bracket with a k helped us get there. Are you ready for the second example? If not, press pause, get these notes down, and get ready for example number 2. Okay, so this one is slightly different. It's still a k-method question, but we don't have a polynomial that's repeating itself. I see a bracket, but in my one bracket there's x minus 1, and then in the denominator there's an x squared minus x. What if we manipulated this question just slightly by distributing that x, not the 4, just the x into the bracket, and then we would see a repetition. If we have an x squared minus x, we could use x squared minus x if we change this question slightly. So have a look. We've distributed the x into the bracket, and now we can replace x squared minus x with a k. So we end up with 4 times the bracket will become 4 times k. Minus 7 equals 2 over that bracket, so which will be 2 over k. Now, remember, when we're simplifying or dealing with fractions, you usually have to find an LCD. When you have an equation, to get rid of a denominator, you can just multiply by that denominator all the way through. So we're going to multiply each term in this equation by k. 4k times k gives us 4k squared. 7 times k gives us 7k. And 2 over k times k will cancel out the k. So now we end up with a fabulous trinomial that once again we can factorize. Now I know factorizing trinomials where there's a 4 up front next to the k squared may be tricky. So I hint at the clever tool on your calculator. Put it in equation mode. Put a as 4, b as negative 7, c as negative 2, and then create the brackets from the answer that's given on your calculator. In other words, fake factorize. We can chat about this soon as well. Please reach out to me if you don't know what I mean when I say fake factorize. Right, now either 4k plus 1 equals 0 or k minus 2 equals 0. So if you were to get k all by itself, we would get k equals negative a quarter or k equals positive 2. I know it feels like we've reached the end, but don't forget, the original question asks us to solve for x, not for k. So now we need to go back to that turquoise rectangle and remember that k actually equals x squared minus x. So let's remember that k is actually x squared minus x. So we can't settle with k equals negative a quarter or k equals 2. We've got to go and make x squared minus x equal to negative a quarter, or x squared minus x equal to 2. And now we solve two equations separately. Right, so by dealing with the equation on the left-hand side, you'll see that I got rid of 4 as a denominator by multiplying each and every term by 4, bring over the negative 1, and factorize. You'll see that you have identical brackets, so there we only have one x value of a half by taking the 1 over and dividing by 2. Here, if we have x, and then on the other side, x squared minus x equals 2, bring the 2 over, and again we factorize. Now x minus 2 equals 0, or x plus 1 equals 0, so we can get the final answer of x equals 2, or x equals negative 1. So here we have 3 final answers. X equals a half, and it's secretly repeated, or x equals a half, or x equals 2, or x equals negative 1. All very easy because we used the K method. Good luck for the exercise. Get it done now. I believe in you.